Well, good morning. Welcome back to the Tin Barn again. I'm Pragmatic Lee. Today's video is going to be just a little bit different. For one thing, there's not going to be a whole lot of FaceTime up front. I'm just going to tell you what I'm going to do, and we're going to get into it and do it. It's going to be a little bit different than some of the projects. So this is my Precision Matthews PM-727M mill, and like practically all of these desktop mills, they have a built-in DRO on the x-axis. I'm sorry, on the z-axis. Now I've added DROs on this one, the iGaging DROs. I've added it for the X and Y on the table, and as you can see, these are the displays for that. I've made an arm for it, articulating arm. What I would like to do is replace this one that's built in, replace it with one of the iGaging ones. This is a good DRO, there's no problem with it, but I'm going to be replacing the displays, the iGaging displays. Going to be replacing those with a Android tablet running Yurley's Touch DRO software. I'll be incorporating Al Bassett's Blu-DRO module. Hopefully that'll be maybe in next week's video that I'll do that. But what I want to concentrate on today is seeing if I can remove this one and putting one of the iGaging scales in there. Now, two things that's going to have to happen. One, I ordered a 6-inch one, and I guess that's 6 inches of travel that this will register. But I got obviously a whole lot more. But these can be cut off. I've got, let's see, 3, 4, 5, 6, 7. This will be the 8th one of these DROs that I've got on my equipment out here, so I'm very familiar with them. They are what they are. They're not as precision as some of the high dollar DROs, but they do work and they serve my purpose in here. By having one of these in there, I'll also have the Z-axis scale over here with the other, so that when I put the wireless device in, all these cords right here will be gone, and there'll just be an Android tablet mounted over here for the display. And of course, that Touch DRO program has several built-in functions like hole patterns, and I really don't know how much. I hadn't even had a chance to look at it other than some demos on the web, but it's very, very highly spoke of. So what we're going to do, as I started saying a minute ago though, it's perfectly fine to cut these off. So once I get in there and determine where and what length I can use, I'll cut these off. I'll cut this off, take these off, and mount down here. So let's start the process now of taking it off. First thing we're going to take off is this hand wheel that in last week's video, remember this was the hand wheel that was originally on the tailstock on my lathe. We'll take that one off. Let me get me some tools over here. I had to seek guidance on how to get these knobs off. I'll be honest, I have peeked under there before, so I kind of know what to expect. But these, I expected to take the set screw out or loosen it. I wound up taking it all the way out. And I expected that handle or knob to pull off, which it did not. It was very tight. So I got on Hobby Machinist forum, on the Precision Matthews subforum on there, and asked if anybody knew what the secret was, maybe if there was a lock ring somewhere. Well, what it is, there's 2 set screws in there. And not only that, there's a ball bearing, 2 ball bearings behind that. So if you take these knobs off, you want to be extremely careful and not lose those ball bearings. And that one's wanting to fall right now. So. It'd like to hit the floor. But there'll be one that rides in the groove, and then one that rides in this hole in here, and there's springs behind them. There's two grooves here that as you turn, and this one is the speed indicator, low-high speed indicator, will indent and fall in that. So be very careful and don't drop and lose those. Alright, come over to this side. Basically I'll do the same thing. As long as you keep pressure on that spring, it's not going to go anywhere. And being left-handed, I can handle this one a lot better than the one on the other side. And that one's got a little grease on it. I guess somebody put some grease on there to keep it from falling out, but the other one's down in there. So now let's take our faceplate off. Well, we need to take these mounting screws. Let me be sure that's still in frame. These are the screws that that fasten the slider in the scale rigid with the spindle. Now remove the faceplate. Alright, I'm going to set my little tub of screws over here out of the way so I don't accidentally bump it and knock them ball bearings everywhere. I guess I kind of expected the DRO housing here, the scale itself, to be mounted to this, but it's not. And I'm pretty sure Matt at Precision Matthews adds these plates on once he gets them in his warehouse up in Pennsylvania. Of course, it's got his logo on it. You can tell this is shop cut out. It wasn't machined out. It looks like a hole saw. And it's got his serial number on it and the date, the sale date. But what we have is a bracket across here that's mounted to the back, and let me see. Okay, this is the DRO. Obviously that's in there. Two screws on the back. Now if we're real lucky, the DRO that I've got, the scales here, would mount on that bracket. But I would really prefer, this one had to come out the front. Obviously you had to be able to see this. What I would prefer in this one is that everything is hid. That it's back in there far enough. Again, I've got to take these brackets off the end and cut it off to length. But I'm hoping I can mount that far enough back in there to so the faceplate will go flush over that and none of this will show. I realize I'll have to put a blank over this, but that shouldn't be too hard to cut out. If that would fit in, but I had already measured, and as you can see, the existing hole is a little wide, 1/4 inch wide, and maybe 1/8 of an inch too high, and I had rather not cut on this. In the event that I need to put it back to stock, I'd rather not have a gap up there. So in looking over this, let me take some brackets off right quick. Now that is sticking out with the black side out. It's sticking out there again, just about 125 thousandths thereabouts. Just glancing at it. That way, it is actually behind the cover plate, but there's really no room for a bracket. Might could get a bracket in there. It'd have to be very thin, but no room for screw head. So what I would like to do, let me mark this, cut it off, and I'll come right back in a minute. First off, let me be sure my quill is all the way up. Really doesn't matter which end I cut off. I'll leave just a little playroom there. Alright, I'm going to cut this off and I'll be right back. Okay, now I've got the new scale cut off and got the length right. Let's see if that's showing up okay. Now, one thing I didn't mention earlier, obviously the cord has got to go somewhere in here. So what I'll do, I can't drill all the way through the back so it comes out the back because the oil reservoir is back there. I would love to come through this side over here if I can find a spot in here that I can get a hole through enough to the end that's on the display itself, feed that through there, because again, remember, the display is going away. Hopefully next week the tablet will be in place of this display, will be the display. So I'll have to put a hole back here for that to go through. I'd love for the wiring to come out of this side, since the wiring for both the other DROs on the X and Y are on this side of the mill as well, and then it can all go to the wireless Al's wireless device, Blu-DRO, that'll be mounted on the back of the mill. In looking at the DRO itself now, setting up here, if it's mounted with the blackout this way, held tight up against this bracket that's going around the spindle, I can see with the scale, there's about 200 thousandths there that is still sticking out. But in this case, the bracket would be in the back. Now, in this section up here that's been milled out, it looks like the same, about 200 thousandths up there with the scale. To be able to set this back, this bracket right here that's on the spindle sleeve around there, the only purpose I can see it serves, other than a stop for when the spindle comes back to the top, is that it is to mount the DRO, to make the DRO rigid. So this hole in here for the scale itself goes back, at least that's 450 thousandths back from that. So I think what I'm going to do is take this off. I've got my mini mill over there, and set this in device on the mini mill and take about 200 thousandths off of this face right here. Now that should put this flush with the front edge, and I would like for it to go down to the bottom as well. That's really, well, it's somewhere in this range in here is where that will go. If I turn it around the way it is right now, I don't have quite as much to have to worry about clearing, but again, the bracket would be over here and the screw heads would be on this side too. So I want to mount it like this. So I'm going to take this sleeve bracket off right here, off the headstock, and, I'm sorry, off the spindle, and carry it over to the mini mill, and it shouldn't be any problem milling about 200 thousandths off of that. I have the sleeve, spindle sleeve mounted in the my mini mill over here now. I chose to do it over here because I need the Z-axis, and obviously the Z-axis is what we're working on the Precision Matthews mill. So I've got it set up now, and I've got it leveled in there straight. We want to take about 200 thousandths off of that, and if need be, I don't have much for metric taps or drills, but if I take all the screw space out of that, or take too much of it out, I'll drill and tap that with some SAE type thread, size thread. But we're going to start out now, and I've got my Z-axis DRO zeroed out over there. I don't really know. I'm just going to start with a very light cut. Getting a little vibration, so I'm not going to try much more than that. That was 25 thousandths. I think that's probably enough. My ways are covered over here for this cast iron. A little more RPM. Alright, we'll just continue down now. I'll take another 25. Alright, that was our 200 thousandths. I probably need to make one more cleanup pass right in the middle. Left just a little ridge in the middle. Alright, while I still have this setting up here, I want to see just how much screw depth I do have left in there. Okay, well, let's come out this way with it. Oh yeah, I still got plenty of depth for that screw. Let's try the other one. Yeah, got plenty of depth with that one as well. Alright, let me clean this up. I'll get it mounted back on the mill. Probably file these edges right here a little bit as well while I've got it off. Alright, that 10 barn measuring with a scale worked out pretty good. I set that up against the stop now, against the ring. It's flush at the top. Travel is good. See if I can hold that on there and take my scale, and I have clearance all the way around on it. Need to rotate that just rotate the ring just a little bit, get it straight, and I have clearance all the way around now. So the next thing I'm going to do is drill these 2 holes in here to mount on there. And just a quick, I'm sure most of you are aware of this, but a little trick when you need to match a hole pattern here, of how you can use your digital calipers to find that distance between there. If the holes were big enough, I could use the inside measurement on the calipers, but since I've got screws just alike here, what we want to do is on our digital calipers measure the width of one of the screw heads. Now, zero out our DRO. Zero out our calipers. Now measure the distance from outside to outside. .470. That is, I wonder what that would have been in millimeters. 12 millimeters. So that's the distance we want to find from the center. We'll divide that in half, and from the center here we'll drill our 2 holes in there to match that. I'll do that off camera and be back. One other thing I want to show you, I'll probably do while I'm off camera. I'm going to take the camera handheld for just a second. Down in here, there was obviously something else when this came from the factory, when it got to Matt in Pennsylvania, and this was ground off to make room for the DRO that they installed. I'm going to clean that up just a little bit there, and that will allow this part to set all the way down a little bit flatter to give me just a little more clearance on the bracket that I make. So I'll be back shortly. Okay, I said I was going to cut that off, but I didn't say how. What I'm going to use is just a little air cut-off tool, and what I'll do is come in here. Okay, I've got this hose on like 40 pounds of pressure. I need to turn the regulator up on this side, but that's the way I'll cut this lip that was left in there, cut off, and then be back shortly. Okay, I have the holes drilled in there in the scale now. Laid those out, drilled them. I've checked them. I cleaned out the bottom of this, so there's the piece that I actually cut out of there. It's just where, again, where the importer cut something off there, not sure what, but as it turns out, I really didn't need to clean that bottom up. It would have been fine. I found an old bracket in my scrap bin over there, and I think for the first time, like I say, this is the 8th one of these iGaging DROs that I've used, and I think this might be the first time I've actually used one of their brackets that they sent with it. But I'm using that as an offset, and I made a little bushing to go in here, calculated as best I could. Mounted that bracket in there, and now with that in there, I see I got just a little space in there, so I'm going to put a washer behind that when I screw it up, when I install it. So I put that in. Let's see, there's a little washer. You'll see in a minute the reason I need to push this top out, or keep the top pushed out just a little bit, making certain it's perpendicular all the way. Well, it's a right-handed world, folks, I promise you. Okay, now we got that started. Let's put our mounting screws into the spindle ring. And using a straight edge to lay across this, I've got that spindle ring twisted on there now, and it's at the same position it was before, so I'll go, or same height. So I'm going to go ahead and tighten that back down now. And get in there to tighten it a little better as when I move it down some. Alright, so that's got clearance. Let's tighten this one up. I will come back and put Loctite on all of these, because a loose mount in any DRO is just like backlash in your lead screws. One of the nice features of having DROs, you don't have to worry about backlash. But if your screws don't stay tight, you'll have some play in there. Now what we're hoping for is that when I come all the way down now and this scale goes below that, there's not any pressure under it. That maxed out to the bottom of the quill, comes back up and it clears fine. Without that washer I put behind there, this was catching on that edge right there, so I think that will work sufficient. I did put some batteries in there and test that it is working. So now the next thing I need to do is drill a hole over here so that I can run the lead wire out, and then we'll start working on the faceplate. As I said earlier, I want to get my this hole for the cord to come out of as far as unobtrusive as possible. I want it to come out this side again because the cords to my other DROs are on this side of the mill, but I don't want it down here where I'm going to get my fingers caught on it when I'm tightening the quill and whatever. So I really like to have it up in here. But of course, you lay your hole out all you want to, but if you can't get your drill in there, it's not of any benefit. So I've pulled the plug on this, or I've made sure the plug was pulled. It's been pulled a little earlier. But I'm going to take this cover plate off, and I'm actually going, if it's not real difficult to do, I'm going to see if I can set this electrical box out of the way so that I can get in there and so I can get my screw up again, or get my hole up as high as possible. Okay. You ever wonder what the inside looks like? There's all the switch points. Snyder Electric. Looks like there's 2 hex head screws holding that in. Gonna be a little hard to get to, but I believe it'll be worth it. Before I take it off though, I think what I want to do is give myself a pencil line under there so I can be sure to stay under that, and of course I can reference it out here. So I'm gonna get this box off. I need to move the camera now so I can get around there, and then I'll bring you back. Okay, just so I don't mislead anybody in saying there was 2 screws in the front of the electrical box holding it on, there was another one in the back, and you can take the back panel off as well as the front and pass all this through there and take it out of the box, and then take the whole box off, and that would have, you know, that would have made getting to the hole a little easier. But I just needed to drill 1 hole down here. So as you can see, I just rigged up bungee cords to hold the box up out of my way while I drilled the hole. Alright, so I've got that hole in there. This was our original line up here at the bottom of the box, right across here. And so we're below that. I've checked and I can get through in there. So I'm going to get this back in place, get everything mounted, then finally we're going to work on the faceplate. Okay, we have the everything mounted, got the hole of course drilled, got our wire run through it. We're mounted back on. Our collar around the spindle is tight, bracket in. I was able to find a 5mm socket head cap screw instead of that Phillips one I had earlier. But everything has got Loctite on it. These have got Loctited. The nut holding the factory bracket to this little scrap piece I found and made a bracket out of. Loctited that nut, and this is Loctited in. So everything should be, and the screws in the back of the bracket are locked in as well. Now our faceplate, when it goes on, of course we got this big gaping hole now. We want to do something with that. So what I've done is just made a little tombstone. I'm going to mount that to the face first. The only thing I had to do, the only modifications I made to the front plate at all, was drill 3 holes in it to mount this little tombstone cover plate. Let me tighten that up good and tight. Okay, so now we can mount our cover plate back on. Done all this and not dropped the screw yet, or not lost the screw yet. I sure hope I can finish it. Let's get all the screws started to begin with. Then to hold our tombstone in at the bottom, we've got a couple of 832 screws. Because that's what I had. And that's got the cover plate on now, with no modifications to the cover plate other than those 3 screw holes that I put in it. And I did tap the housing for those 832. So now we're ready to put our knobs back on. Now again, we want to be extra careful with the ball bearing. The two knobs are just alike. We've got some very fine needle nose here, and I know I had this in the high position. So I'm just going to locate that ball bearing in that high. Press it on there. Press and hold. And hopefully I can find the go. The intercept screw will find its home when you get it close. So lock that one down plenty tight. And the ball bearings will work. Alright, I'm going to move the camera out of the way since I'm left-handed, get to that other side, and I'll bring you back after I get the knobs on. Okay, so just a quick recap. I removed the built-in Z-axis DRO, this one, which I think may work extremely well on the tailstock on my lathe. The display will be turned sideways, but I believe I could read that, and it's a whole lot stouter than that little cheap digital caliper I put on there. So I'm sure I'll find a use for this. Remove the stock one, made a mount for, put the iGaging DRO in. Had to mill the collar ring on the spindle down just a little bit to set that back about 200 thousandths. Put a hole over in the side over here, run the cable out, run around that side. Remember now, the whole reason for doing this, these displays are going away. Maybe in the next video, if not within the next couple weeks anyhow, I'll be installing Al Bassett's wireless controller board for the Touch DRO software package. What will happen is a Android tablet will mount over here. Just from what I understand, most any of the Android tablets, if you look up Touch DRO on the web, you can find the specifications. But it is a full DRO package, open source software, which if you're so inclined, you can get in and modify yourself, recompile. Runs on the Android devices, but it will be a display that will have X, Y, and Z. Also has capability, I think, for a tachometer, and has numerous built-in programs, built-in functions to it. That will replace these three LED or LCD displays that are over here now, and will be a nice display, very easy to read, much larger than this. I've already got a mount made. I made this out of 1-inch aluminum bar stock. So hopefully that'll be coming maybe in the next video. The tombstone that I put over here to cover that hole, it's visible now because we're all looking at it, but I think soon it'll just become part of the landscape. Hope you enjoyed this, and comments, thumbs up, subscriptions are always appreciated.